Hi everyone, I hope you're okay. This is the third video, guys, which simply means I'm doing question 3 from the 2023 KZN November Mathematics Paper 2 exam rather. Please note that there are already 2 videos being uploaded, and there will be 6 videos after this one. Just click the link on the description below. It will take you straight to the playlist with the full memorandum. You can download the question paper, and if you can't find it anywhere on the internet, you can take a screenshot, answer the questions with me. And if there are things you're not sure about, please do write in the comment section. I'll just come back and assist you. And please don't forget, guys, to share this video to your peers. Maybe form a group study just to prepare for your examination. And don't forget to like and subscribe as well. Okay, in the diagram below, A, B, C, and D are 4 vertices of a quadrilateral. Okay, the first thing they want us to do is to calculate the gradient of AD. We do have 2 points there, points A and D. We can find the average gradient. So the gradient of AD is simply y2 minus y1 over x2 minus x1, right? This is simply the y value at D minus the y value at A all over the x value at D minus the y value at A, and this will give me negative 4. It will be negative 4 over negative 10. I'll just get 2 over 5 as my gradient. 2 over 5 is my gradient. Okay, so the gradient of line AD is just 2 over 5. Okay, now I'm supposed to determine the equation of line BC, which is parallel to line AD. The equation of the line BC, which is parallel to line AD. Remember that, guys, whenever I'm told that lines are parallel, it simply means that those 2 lines have the same gradient. Right, together. So AD is parallel to this one. That means the gradient of line the gradient of line BC is also 2 over 5. Are you together? Is also 2 over 5. So for me to find the equation of a line, I need 2 things. I need the value of the gradient and any point on the graph, né? And then after finding those 2, I'll just substitute them on this equation that says y minus y1 is equal to mx minus x1, right? Where both y1 and x1 represents the point on the graph, and then m just represents the gradient. Okay, y1 is just negative 1, x1 is a 2, and then my gradient is 2 over 5. So I'll simply have y plus 1 is equal to 2 over 5x minus 4 over 5. Then y is equal to 2 over 5x minus this will give me 9 over 5. Let me check. 4 over 5 minus 1. Yeah, that's 9 over 5. So the equation of my line y is simply 2 over 5x plus 4 plus 9 over 5. This is the equation of my line. No, it's not plus, man, it's negative. Okay, now I'm supposed to determine the coordinates of E, the midpoint of line BD. The coordinates of E, the midpoint of line BD. How can I find the coordinates of the midpoint? There is an expression there by the formula sheet. It's given by m. M is x1 plus x2 all over 2, and then y1 plus y2 all over 2. But since now our midpoint is not m, our midpoint is e, so we are not going to use letter m, but we will use letter e. Né? Please note that, guys, whenever I'm finding my midpoint, I'm not saying e. I'm not saying e is equal to, then substitute. This is wrong. Né? Please make sure that you write the equal sign before you even write anything. This is equal to e, and then I'll simply take the x value at d, which is negative 6, plus the x value at b, which is 2 all over 2, plus and then for y I'll take the x value at d as well, plus the x value at b all over 2. This will give me I'll have negative 4 over 2, which is just negative 2, and then I'll have negative half. So the coordinates of e, negative 2 and negative half. Those are the coordinates of e. Negative 2 and negative half. Okay. Given that ABCD is a parallelogram, calculate the coordinates of point C. Given that ABCD is a parallelogram, they want us to find the coordinates of point C. How can we do that? Whenever I answer this question, guys, you must remember the properties of a parallelogram. Né? The properties of a parallelogram simply says that opposite sides are parallel and equal, and the diagonals bisect one another, which simply means that EC is equal to AE. Why? Because the diagonals bisect one another. So I can simply say, for me to find the x value at E, which is the midpoint, I must simply say the x value at A plus the x value at C all over 2. Then I must do the very same thing for y. For me to find the y value at E, I must take the y value at point A plus the y value at C, divide them by 2. Okay, let's start with y. The y value at E is equal to negative 1 over 2. The y value at A is 4 plus the y value at C all over 2. Né? Whenever I multiply both sides by 2, I'll be left with negative 1 is equal to 4 plus the y value at C. So the y value at C is simply equal to negative 5. Okay, let me go and find the x value. I know that the x value at C is negative 2, right? And the x value at A is 4. I want to find the x value at C. Okay, I'll just multiply both sides by 2. I'll simply have negative 4 is equal to 4 plus the x value at C. Therefore, the x value at C is equal to negative 8. So the coordinates of C, I have negative 8 and negative 5. So my coordinates of C, I simply have negative 8 and negative 5. Okay. Given the points P, Q, R, and S, determine the value of x if PQ is perpendicular to RS. Okay. I'm given PQ, R, and S. Né? Let me indicate this. Let's say we have points you have P and Q over here, and then we have R, maybe S is over there. And we are told that these two lines are perpendicular like this, ne? So which simply means that the gradient of PQ multiplied by the gradient of RS, they'll give me -1. So if I can find the gradient of PQ, it will be easy for me to use it on finding the coordinates of X. How can I do so? The gradient of PQ, excuse me guys, the gradient of PQ, I simply have to say y2 minus y1 over x2 minus x1, right? I'll take the y value at P, which is 3, minus the y value at Q, all over the x value at P minus the x value at Q. This will give me -1 over -3. That will give me 1 over 3. Are you together? If ever, guys, I have two lines which are perpendicular, excuse me, I have the gradient of one line, I must just find the gradient of the other line. I'll therefore, for me to find the gradient of line SR or RS, the gradient of line RS, I must just take the gradient of PQ, flip it around and change the sign. That's all I need to do. Are you together? Every time, guys, whenever we have perpendicular lines, we have the gradient of one line, you want to find the gradient of the other line. Take the gradient you have, flip it around and change the sign. Always the time, né? So if I flip this number around, I'll have a 3 over 1. I don't need to write the denominator, and then I must just change the sign. I'll have a negative like this. Are you together? But I know that for me to find the gradient, M of line SR is equal to y2 minus y1 over x2 minus x1, right? The gradient is equal to -3. Are you together? And then the y value at point X is 4, and the y value at point R is 1. The x value at S is X, and the x value at R is -4. Okay, I'll simply have -3 being equal to 3 all over X plus 4, né? I'm just solving X now. I must just multiply both sides by X over 4, né? By X plus 4 rather. Let me continue on the side. Whenever I do that, I'll simply have -3 X plus 4 being equal to a 3. I can divide both sides by -3. I'll simply have X plus 4 is equal to -1. Then X is simply equal to -5. So for the coordinates of S, I'll simply have -5 and 4. That's how, guys, we would have tackled the third question. Please, guys, stay tuned and wait for more videos.